Okay, so let's go over some basic properties of logarithms that will help you to simplify and evaluate log expressions. So first of all, let's talk about property number one. So the property number one says you logarithm of b with base b is equals to 1. So this means logarithms of the base to itself is always 1. It's because b to the power 1 is equals to b. So here the base is equals to b and exponent is equals to 1. So base of the output b, the exponent is equals to 1. So property number 2 is logarithm of 1 with base b is equals to 0. So this tells us the logarithm of 1 is 0 no matter the base is. Why? Is it because we know that b to the power 0 is equals to 1. So it doesn't matter which base we have. If you raise any number to the power 0, you'll get a 1. So property number 3 is logarithm of b to the power x with base b is equals to x. So this shows that logarithms undoes the exponent. So it is the inverse operation of exponentation. So you're basically saying what power of b gives b to the power x? The answer is x. Next, property number 4. So this is property number 4. So this is the reverse of the previous one. So if you raise b to the log of x and it gives you back x. So again, logs and exponent undo each other. Property number 5. So property number 5 says if you have two numbers which are equals to each other, then you can take logarithms on both sides of that equation. So if m and n are equals to each other, then logarithm of m is equals to logarithm of n. You can use any base. So this says if two numbers are equal, then their logs are equal too. So it's a reminder that logarithm preserves equality, a useful idea when you're solving equations. So these properties are very useful. In summary, they help us to simplify expressions, let you solve equations, so how logs and exponents are inverse operations of each other. So now let's try some examples where we can use these properties. So let's use basic properties of logarithms to simplify the following expressions. So let's start with the first one. So you're asked to get log of 5 to the power 10 with base 5. So you have to, so I hope you remember the identity. Log of bx to the power base b is equals to x. So if you use this identity, the answer for the first part is really simple. The answer will be equals to 10. So log of 5 to the power 10 is equals to 10. Moving on, the second example, you are asked to take logarithm of 4 with base 4. Again, we are going to use the identity log b of base b, which is equals to 1. So here the answer will be equals to 1 because this we can use this identity to solve this logarithmic equation. Next, the third part. So next we are going to take logarithm of 1 with base 4. So we know that if you raise any number to the power 0, you get 1. So here the answer is 0. Again, I used the identity where it says log b1 is equals to 0. Okay, moving on, D, log 10, 7. So this here you don't see a base, which means the base is 10, the common logarithms. So here what you can do is you can again use this identity because it is same, the base is here 10. So if you use this identity, the answer will be equals to 7. Part E. Then you have to get ln e to the power 3. So here ln means this is natural logarithm. So this is equivalent to log e to the power 3. Again, we can use this identity. So here the answer will be equals to 3. The final part, you are asked to get logarithm of 10 over 10 to the power 3. So you can write 1 over 10 to the power 3 as 10 to the power negative 3. So here I have brought this denominator to the top. To do that, I'm going to make this exponent negative. And here you don't see the base, which means this is a common logarithm. So this is with base 10. Again, using this property, the answer is equals to negative 3. Okay, so now you have learned basics of logarithms. So now let's talk about 3 important properties that help us to expand, simplify logarithmic expressions. So these are called product, quotient, and power rule. So first of all, let's talk about product property. So this property means logs of a product is the sum of logs. So you can think it like as multiplication becomes addition. For example, let's say you're looking at logarithm of 8 multiplied by 4 with base 2. So you can expand this and write as a sum. Like you can write this as logarithm of 2, 8 plus the log of 4 with base 2. So here we have applied product property. So now let's go to quotient property. So the quotient property tells us the log of a fraction becomes the difference of the log. So you can think this as the division becomes subtraction. For example, let's say you are looking at log of 9 over 3 with base 3. So you can rewrite this as log of 9 with base 3 minus log of 3 with base 3. Property number 8. So this property we called as power rule. So this means when you have an exponent inside the log, when you have an exponent inside the log, you can bring it out front. So here you have exponent inside the log, so you can bring it out front. So here you can move this here and you can rewrite this as k multiplied by log m. For example, let's say you have log of 2 to the power 3 with base 5. So you can rewrite this as, since you have an exponent inside log, you can bring this 3 to the front. So this is 3 multiplied by log base 5, 2. So in summary, we have 3 important rules and they are called product, quotient, power rule. So in product rule, what happens is multiplications becomes addition, and in quotient rule, the division becomes subtraction, and here the exponent comes to the front. So let's try some examples where you can use these properties. So let's start from here. So here you have log of this expression. So in this expression, you have 2 terms and you have the product of 2 terms. So which means for the first part, you can use product rule. So if you use the product rule for the first part, you get log 4, the first term is 5, plus log 4 x minus 7. So remember, when you are trying to apply the product rule, make sure that the base is same. Moving on, second part, here again you have a logarithmic function. Here ln means this is a logarithm with base e, and inside you have product of two functions, which means again you have to use the product rule. So if you use the product rule, you'll get ln e to the power 2 plus ln e to the power 3. Okay, so this is how you apply product rule, but still we are not done because we can simplify this further. So we know that natural logarithm of e to the power 2 is equals to 2 using basic rules. So you can apply that over here and you can write this expression as 2 plus ln e plus 3. In C part, you have a quotient inside the log term, which means you have to use the quotient rule. So once you use the quotient rule, you'll get something like this. Log x minus 8 minus log x. So here you don't have a base, which means you are automatically dealing with base 10. Next we have D. In D, you have an exponent inside the log function, which means you have to use the power property. You have to use the power rule. So log 4y6 equals, here you have an exponent, you can bring that to the front. So 6 multiplied by log 4y. So you cannot simplify this further, so you can leave this as it is. Part E. So here we have ln 1 over x to the power 5. So here I'm going to rewrite this as ln x to the power negative 5, and I'm going to apply the power rule here. If you apply power rule here, it's going to be negative 5 ln x. In power rule, you can bring this exponent to the front. Okay, example number 3. Here also you have to use the properties of logarithms, but in a reversed way, because you have to write all these expressions in a single logarithm terms. So first of all, I noticed in first example I have the same base, which means we can apply logarithmic properties. So first of all, here you have to move this 4 inside this log term. To do that, you're going to use the product rule. So you can write 4 log 3y as log of y to the power 4 with base 3. So here I have moved this 4 inside the log using power rule. So here I have used power rule. So now let's get back to our problem. So the problem says we have to evaluate log 3x plus log 3 y to the power 4. So now we can apply product property here. So now I'm going to use the product rule here. And I'm going to combine these two. Since I have the same base, I can write these two as the product. So it's x multiplied by y to the power 4. So this is the answer. Moving on, the next example. Here also we have to combine them together, but first of all we have to get rid of these constants. So let's move these coefficients inside the log term. So first of all, let's move this half using a power property. So you can write this as log a to the power half, and 3 log b, you can write this as log b to the power 3. Now let's try to combine the two terms. So half log a minus 3 log b is equals to log a half minus log b to the power 3. So now it's the difference, so which means you can use the quotient property. So I'm going to use the quotient rule, and I'm going to rewrite this as log a to the power half divided by b to the power 3. So this is a single term. Part C, again you have to rewrite this. So to do that, first of all, let me move this 3 inside log term. So 3 log, okay, it's not log, it's natural logarithm. You have ln z. So this is equals ln z to the power 3. So now let's go back to my problem. The problem says we have ln 5x minus ln z to the power 3. Again, we have a different, which means we can use a quotient rule. So this is going to be ln 5x over z to the power 3. So you have to use the parentheses here. So let me rewrite this. So this is your answer.